Hi, everybody. First of all, I want to thank Jelko AI Association for opportunity to present this project, SENDD AI system that detects neurological deviation detection or disorders. For us, it's not a regular project. It's not, let's say, business as usual project. For us, we think this project is a huge contribution in medicine, especially in infants healthcare. And I personally think that every parent in this room or in a city in Zagreb, Croatia, worldwide, can identify with the benefits of this project. So, I'm TOMISLAV STRGAR. I work as a project manager in TIS. Here with me is GORAN, doctor from Dr. SABOL POLIKLINIK, neuropediatrician. He will talk about the medical perspective of this project. Before him, I will talk about little facts about the TIS. We are established 30 years ago. We have 4 companies in Croatia, Slovenia, UK. Have more than 100 professionals in with different expertise from IT development, project management, agile, business analysts, AI, machine learning, and so on. We also deliver projects in financial industry, telco, healthcare, public sector, and so on. As you can see, we have the largest partnership level with the biggest vendors in the world. So, Goran, the stage is yours.
Thank you, Tomislav, for the introduction. I'll take it from here. Polyclinic Dr. Sabol is private polyclinic, more than almost 30 years ago, founded by Dr. Zlatko Sabol, first private polyclinic in Croatia. But things that we are going to talk about now is some idea that's not that new, but it's new in machine learning, and as you might find at the end that it's quite a good case for AI to learn. So here am I. I was born, and not everything went fine. Doctors told me that I have risk for development. I might have a brain damage, but they're not sure. And with available methods, even if they manage to prove that I have a brain damage, they cannot be sure what impact will it have on my future development, exactly what outcome will it be. Will I go to school? Will I be able to walk? Will I be able to talk? Because brain is still in development, it's plastic organ, we cannot be for sure. So when a new member comes to the family, and with everything that new member brings to that family, there are many steps on the way that this child needs to take. Needs to see a lot of doctors, a lot of tests, a lot of brain ultrasound imaging, maybe even magnetic resonance imaging, to see a lot of specialists that don't always use the same language. And even if they use the same words and speak the same language, I'm not sure that parents always understand what we are saying. And not only that, one thing that all doctors agree, and they all tell to the patients and parents, is that there is a need for long-term follow-up. What that means, it means that you have a long-term uncertainty. We are not sure. And when we say that we actually don't know, because there is no possibility to know early in development what outcome will it be. Brain is a plastic organ, and because of that, some small lesions in the brain can disappear, and brain can function normally. But one thing that also means to be uncertain is to be subjective. And when you lack information, then you get more subjective. And you're subjective in making judgments. And the idea is to be more and more objective as you possibly can. But not only that, it was proven that in the long run, it creates even more stress than the actual realization that something painful or unpleasant will happen. So it's better to tell in the beginning, expect problems, than tell we need long-term follow-up. So it's stress for years to the parents. So imagine, what if? Imagine there is a method that's simple, that's early available, that is repeatable. It's non-invasive, it's safe to use, it's reliable, it's standardized, it's checked. It's evidence-based, proven, and validated repeatedly. There is even a possibility that the child doesn't have to go anywhere, so-called telemedicine. You can do it at home. And the doctors only need to watch. We don't need to poke needles, only to watch. Well, there is such a method. More than 3 decades ago, Professor Prechtel published this scientific paper about qualitative changes in spontaneous movements. They're a marker of neurological dysfunction or normal function if there is a normal quality. He described that method as a powerful diagnostic tool of truly non-invasive nature. 15 years later, he published this scientific paper where he proved that there is a sensitivity and specificity of 95% for that method in the assessment of spontaneous movements, and that it's fast, it's non-invasive, and it's more cost-effective even compared to other methods, for example, magnetic resonance imaging. He called it methodological breakthrough. Well, for some reason, we still don't use it in everyday practice, although it tells a lot. So not only Professor Prechtel and his group, many other scientists and scientific groups for all parts of the world repeated his results, checked, rechecked, made systematic reviews and analyses, and concluded, this is just one of the papers, that this method, quality of general movements, can serve as a prognostic tool for identifying infants with neurodevelopmental abnormalities early. And if you are looking for a safe, cheap, and effective test, we found it. So what is this? What is that simple? And we don't use it. This is general movements. These are general movements. When you watch a child move, fidget, at the age of 2-3 months, we think that nothing actually really important happens. Movements are not related to some outside stimuli. But actually, what happens is very important. Child learns by doing that. It's calibrating its brain. It's connecting neurons from motor cortex to the tip of the finger. So what we call general movements, if normal, general movements include all parts of the body. They're complex, they're variable, they're fluent, they're wax and wane in their strength, intensity, and speed. They have gradual beginning and gradual end. That's how it looks like if everything is normal. But what actually happens in the background, newborn brain has a massive number of neurons. It's estimated about 100 billion neurons. And those neurons, during phases of growth and development, are connected and interconnected with astronomical number of connections. Can you even imagine what that number would be? It's huge. In addition to that, young brain has even more neurons than the adult brain. So you gotta ask yourself, why isn't newborn brain more functional than an adult's brain? Well, the reason for that is the brain constantly changes. It's plastic. Even now here, where we talk and you listen and to this lecture, your brain is changing. That's the reason why neurological examinations are age-specific. You cannot expect of a child 3 months old to walk or talk. You have to be specific for the age, what to test. To have a neuro risk for future development does not mean you have a diagnosis. It means you have a risk. It means you have uncertainty, you're not sure. You have stress. Because for any specialty in early development, it is very difficult to predict future outcome because of that brain plasticity. So what happens with our genes? Our genes are responsible for developmental selection and blueprint of our brain, just to have a structural normal formation of the brain. But for functional part, for most of the functional part, brain has to learn it by itself, literally by trial and error, trying out all the activities and combinations of activities they can. So if those impulses happen in the motoric part of the brain, motor region responsible for movement, you will have in the rest of the body variable movements that are actually trial and error, trying out all the combinations that can do in motoric part of the brain. And we see it as a fidgety in the infant. And infant fidgets for months. Theory behind all of that explains it, it's a neuronal group selection theory. When you go into more detail in that theory, you see quite a lot of similarities to the way how AI learns. It's literally calibrating itself. So what if there is an early brain damage? You can assume that if you lack most of the neurons and pathways from neurons to neuron, that you will have an exponential decrease in the possibilities that that brain can perform. And as a consequence, all the motor repertoire that that brain can produce will also be reduced, both in temporal and spatial variability. So what it means is that by time and every second, every minute, that's the temporal component, and spatial is just to explore everything he can in all combinations of all the extremities will also be reduced. As a consequence to that, in later stages of development, when we expect the child to sit, to walk, or to talk, best solution, best strategy that some child can do, for example, walking or to grasp some object, can also change, be different than for the healthy child. And then we see that as a neurologic problem. But the neurologic problem was there from the beginning. So we have on the left side, you have a normal child. This is just few seconds. Interval between these two frames is 0.2 seconds. So it's just a few seconds of the recording of the child fidgety. You get the impression of complexity and variability. You won't find the same picture. Even if you record the child for hours or for weeks, you won't find the same picture. Even if you do find the same picture, pictures before and after that one won't be the same, because the sequence that the child came to this moment was different. It's constantly changing. On the picture on the right, you have abnormal general movements. You get the impression not of complexity and variability. You get the impression that the child does not move. It does move, but it moves very simple and stereotyped. GMs, general movements, lose their complexity and variability. So those are two extremes. In between is a continuum of quality of movement. And in continuum of that quality of movement, we as doctors who are trained to make quality assessment use simple gestalt. We just experience by watching. And it can get subjective. And that adds to that stress. But if you use artificial intelligence as a mean to objectively use this continuum from abnormal to normal, and to validate and to repeat to get the objective result, that's the place where AI can help us a lot. And that's where Tomislav takes it from here. Thank you.
Okay, thank you. Now a few words about the project in general. SENDD is an acronym for Early Neurological Deviation Detection. To be more precise, the purpose is to build a unique AI solution for assessing the quality of spontaneous movements / fidgety movements. Our target, as you can presume, are children that are just 2 or 3 months old. Why? Because that period, as Goran said, is the best time for detecting potential neurological disorders or some neurological risk. Our goal at the end of our project is to build the AI system that automatically detects that neurological disorders or neurological risk infants. This project is made in cooperation with Dr. SABOL Polyclinic, also is co-financed by European Union funds for research and development. This is 3 years 3 years project. Currently we are in researching phase, and from the next year we are entering in development phase. Okay, something about our AI system. Our AI system consists of two parts. First part is for video pose estimation. And here we had some challenges. Somebody will said why this is a challenge, because there is on the market already trained neural networks. I can agree, but for adults, not for this kindly baby. So there was three challenges: find the most suitable annotation tool, find the key points for annotation, research the best machine models and neural network architecture. So after we researched and tested few annotation tools that are available on the market, we developed our own this annotation tool for in Python. Also, we decided to annotate 15 key points on infant's body, 3 per limbs and plus eyes and nose. Also, something about the inputs. As you can see, our inputs in this phase, in these parts, is videos of fidgeting. On other side, on output side, we have three outputs. First output is video with annotation and JSON file with the coordinates of all key points / infant's body part. The second was composite map, the visual representation of all movements during the video. And the third part is just the single part of that image, the single part of every body part, such as the right wrist, left ankle, right ankle, and all of them of 15 key points. That's about, just to mention that three outputs in this part of our system are inputs in the second part that is for fidgety movements assessment. I will talk later, in a few slides later. Something about our currently data set. Our currently data set is more than 50,000 annotated frames that are annotated through our annotation tool by our internal annotation team. We have videos from 4 countries, and the current results are, so not current results, the best machine learning models that we got are ResNet 80 and ResNet 50 and DenseNet. Okay, we are going now in a second part of our system that is for fidgety movements assessment. Here is the first challenge. How and what about the classification? The classification before AI. As Goran also already mentioned, we have 2 classification systems by Professor Hader-Salgra and Professor Prechtel. We decided to use 4-class classification system by Hader-Salgra. Also, for every video we do analysis. We are checking if every video before manual classification satisfies medical and technical conditions, such as if baby is laying on the ground, if light redressed, if there is no external influence, because some external influence can impact on fidgety movements, and so on. Also, some technical requirements, if there is a good lighting, if perspective is from bird's eye perspective view, and on the end, Dr. Sauer Polyclinic team is doing manual classification. And when we got them classified every video, then we go to take it to our system and try to train our neural network. The second challenge here was find the best machine learning model and architecture. Till now, we tested and researched more than 22 different models and algorithms versus 3 different inputs. Also, here is the results that best machine learning model is CNN network, K-means, KNN, SVM, ResNet, etc. Some other statistical information are per training, days per training, needed days per training. Also, currently, our dataset consists of more than 400 videos of fidgeting from 4 countries. And currently, this is our final results so far. In 4-class system, we have accuracy between 65 and 70%. But if you look in a binary perspective, if you are just trying to look if fidgety is okay or not, we have a little bit better results. I need to underline that these results are from researching phase. So we hope so that in development phase and in the end of phase, we will have much better results. But for us, these results are great. And finally, the third challenge was how to gather representative data sets of video with fidgety movements. This presentation is just one way to increase the awareness why fidgety movements are so important. Dr. KRAKAR also said why fidgety, why general movements, why spontaneous movements are so important. So every team from Dr. SABOL Polyclinic or from TIS are doing our best to present method characteristic that is not invasive, that is medically proven, that is completely harmless. For every video can be taken in baby's known environment. There's no need to go to polyclinic or go to hospital. Also, for the end of this presentation, I just want to invite all parents of children between 2 and 3 months to participate in this huge project. More information or some details can be found on our webpage or Facebook page, or you can ask now or later on a coffee breaks and so on. Send us fidgety movements. That's all.
If there are any questions, feel free to ask, okay?
Thank you. Well, first of all, bravo, this is a really great effort. Second, I'm interested in whether it's possible, do you think it's possible to map certain neurological disorders to these fidgets, and do you plan to push an endeavor in this direction sometime in the future?
First part I will answer. You have to go from fidgety to neurological disorders. We cannot go backwards because in this stage, when the brain is wiring and connecting, and we call this synaptic fingerprint. There are no two persons with same synaptic fingerprint. We are all connected differently. And while that is connected, it's spontaneous. It just happens. You cannot go from, okay, this child will have this kind of neurological disorder, and we can see that if that will happen while fidgety. We just can see, is it normal? Is it mildly abnormal? Is it definitely, how abnormal is it? And how high risk will it be for a developmental disorder? For example, you have a child born at the age of, I don't know, gestation 30 weeks prematurely, 2 months premature, and lack of oxygen and infection and bleeding in the brain. And we say there is a risk. There is a high risk that something will happen and that child will have problems in walking or epilepsy or cerebral palsy, be in wheelchair. But also it can function pretty normal or totally normal, depending on the brain lesion. And one thing is you can follow up and see what comes up and have early intervention. But you have also very large number of infants that are at risk for developmental disorder. But if you check early, what you can check early, and you see normal fidgety movements, you can tell parents, yes, there still is a risk, but we expect to be normal. We have to follow up, but expect normal. There's a huge difference. If you have a child with the same story and has abnormal movements, then you can tell to parents, yeah, expect problems. We don't know how big problems, but some consequences will be. But the level of stress you take away from that parents, if you have told them there is a risk, but expect normal, is huge. And that's where this method will help. And to connect with Tomislav's part of the answer, it's a tool to help, not to self-diagnose. Because of the huge number of child at risk for developmental disorder, it's a method just to screen from, I don't know, 4,000 of risky children per year, to screen those that actually need doctors and need early intervention. The rest of them will be fine.
Yeah, okay, thanks. I was just actually curious whether this was mentioned in the research. So the next step in the pipeline is obviously a higher frequency of medical exams, right? Within those cases which have abnormal behavior. I'm also curious, can this fidgeting improve over time? Can it disappear in certain individuals?
Yeah. It can change. Yeah, it can. It has certain periods where it can get better or not better. But you can evaluate fidgety movements, general movements, even in the preterms. You can evaluate general movements in the age of 2-3 weeks in term children. But the highest quality and highest prognostic value of fidgety movements is at the age of 2 to 2.5, 3 months. That's the reason why we chose that period. Because if we assess too early, because of the brain plasticity, it can happen to get better. And then we still don't have the same level of exact results. That's the reason why we chose that period. And it's easier for the parents to, if you're still in hospital and the child just got home, it's very difficult to get those recordings. At the age of 2 months, it's much easier and more practical. And it's prognostically has a higher value.
Sure, thanks.
So nice using child's picture. It's proven that they provoke attention, and you use not only pictures, you use videos, hundreds of videos. So it's known that it's difficult to work like technical project in a health industry these days because all the necessary regulation and permits that you need to get. So everybody's trying to avoiding it. So how did you overcome this? And did you approach to Poliklinika of Dr. Sabol, or they approached to you? Because, if somebody wants to do similar problems and find research 20 years ago that can apply some AI and solve the problem, they want to know that.
We have a history before this project because in Poliklinik Sabol we started one little project for patient ordering, digital archiving and so on. And we asked them if you have any idea for that we can apply to innovation and research European funds. And Goran said that he has this great idea how to digitize this method. So that's the answer for the second part of question. And for the question about the GDPR, first month we have paper. Every parent needs to sign that give us consent to that we can use the data, to use the video for analyze and so on. From May we have this web page where every parents can do online onboarding and sign, accept the consent and all terms and conditions.
Okay. Do you have any more problems that you need to solve? So somebody can come and ask you for the problems.
You ask a great question because that actually is a problem. We every day. For I don't know, maybe 10 times every day I speak the same sentences and invite parents to send videos or to come to the polyclinic so we can record the video, but for some reasons technically it's better to do it at home. Sometimes when you see 12 pages of GDPR and they see artificial intelligence and machine learning, you get curious responses from some people that don't want to do it. Or some even ask, we want to do it, but we don't go into that project, just check. So yeah, I don't know, maybe if 10 of them, I share that story to 10 of them, maybe three will actually do it.
Okay, so be persistent.
We are persistent. We are persistent. There is some, I don't know how to explain
Okay.
reluctancy to AI.